I have some cubes that are centimeter cubes, I have some cubes that are 2 centimeter cubes, and I also have inch blocks. And I leave them all out on a shelf, and I let each gopher from each group go select whatever bag they want. So some kids want to work with the snap cubes for whatever reasons. Some kids want to use cubes that don't snap together. Just in this last year or two, we're getting more access to technology, and Pearson's actually provided a nice app that allows kids to they can actually build three-dimensionally on their computer screen. They can try to build these representations of these different prisms, and they can look at them, one cube being laid in this prism at a time. I think it's important for us to figure out how kids are counting these cubes and to make sure they actually are counting cubes to get the volume of a shape. It's a different concept from what we've done with area, with two-dimensional measurement, and perimeter, which is one-dimensional measurement. And so I'm constantly going around the room asking questions to try to understand, do the kids understand what it means to measure volume? And for our definition, we're measuring volume by the number of unit cubes that it will take to fill whatever object we're using. So in this case, in the rectangular prism, I want to hear those kids telling me things like, well, we counted the total number of cubes in this shape. And I'll ask, can you be more specific? Can you tell me how you counted them? And I'll actually ask kids to actually show me and point with their fingers, because what I'd like to see is, did they really count all the cubes on the bottom layer and then count their layers going up? Did they count all the cubes on the front face and count the layers going back? Did they count all the cubes on the right face and count going to the left, the sets of? Because those counting methods lead to equivalent formulas, but different ways of looking at formulas for the volume of a rectangular prism.